As we all know, light travels at nearly 300,000 kilometers per second. To be exact, 299,792,458 meters per second, with only a tiny margin of error. That means in just 1 second, light can circle the Earth about 7 times. Each lap takes only about 0.14 seconds. Light is the undisputed speed champion of the universe. To this day, we still haven't found anything faster than light. So, what exactly is light, and why does it move so fast? According to Wikipedia, light is a form of electromagnetic radiation with wavelengths ranging from about 380 to 700 nanometers, the range our eyes can see. Light travels as both waves and particles. Those particles are called photons. White light is a combination of all visible wavelengths, from violet to red. Violet light has shorter wavelengths and carries more energy, while red light has longer wavelengths and less energy. If light contains only a single narrow wavelength range, we call it monochromatic light. In simple terms, light is made up of tiny particles, photons, that have virtually zero rest mass, moving at incredibly high speed. In empty space, light travels at almost 300,000 kilometers per second. In Earth's atmosphere, that speed drops only slightly by just a few dozen kilometers per second. But in glass, light slows down to around 200,000 kilometers per second. This proves that light's speed isn't fixed. It depends on the medium it's moving through. So, can we ever travel as fast as light? The answer is, not with our current technology, and probably not anytime soon. And what about the distant future? Again, probably not. Einstein's theory of relativity tells us that as you approach the speed of light, your spacecraft's mass would increase toward infinity. That means the energy required would also grow without limit. Here's an example. If you could push a spacecraft to 99% of light speed, you'd need an amount of energy comparable to an entire star. Going any faster would require even more, essentially infinite energy, which is impossible. So why do we still dream of reaching light speed? Because the universe is so vast. Light speed might seem incredibly fast on Earth, but on a cosmic scale, it's barely a crawl. Our closest star, Alpha Centauri, is more than 4 light years away. Without a way to travel at light speed or faster, we might never reach other stars. And what about distant galaxies? Some are millions of light years away. They might forever remain out of reach. Beautiful spots we can only admire through telescopes. Although traveling at the speed of light is impossible, we don't need to feel disappointed, because human intelligence is limitless. Throughout history, humanity has witnessed countless great inventions that have changed the face of the world. And at the beginning of the 20th century, people could not have imagined that air travel would become as common and simple as it is today. Even now, many people on Earth don't know or even believe that humans have actually set foot on the moon. So, inventing a spacecraft that travels at the speed of light might only be a matter of time. But if we truly manage to build a ship that travels at the speed of light, what would happen when we're on board? First is the issue of collisions. If we travel at the speed of light, approximately 300,000 kilometers per second, then any object, even one as small as a bean, could cause a catastrophic impact, more powerful than any nuclear bomb. Second is navigation. At such immense speeds, our spacecraft would need a completely new generation of ultra-advanced steering systems to avoid any obstacle in time. That would be extremely difficult. Next is visibility. With our naked eyes, we cannot see objects moving extremely fast, like a speeding bullet. If we were to truly travel at nearly the speed of light, our eyes probably wouldn't see anything at all. Perhaps everything would look like a white blur. And if a powerful enough camera could record the journey, all surrounding matter would seem frozen. Even photons would appear still, since we'd be moving alongside them. Everything around us would almost come to a standstill. and we could truly touch time itself. The universe is a three-dimensional space where time is nearly a fourth dimension, yet we still don't fully understand time. What can change time? It's gravity and velocity. That's right. This seemingly impossible idea is true. Time slows down if you move extremely fast or if you are near an area of intense gravity. For example, let's take two identical clocks, one placed on the ground and one at the top of a 100-story building. After 1,000 years, these two clocks would differ by about 1 second. 1 second doesn't seem like much, but near a region of immense gravity, the time difference would be significant. The region with the most powerful gravity we know of is a black hole. If you were to fall into one, your time would nearly stop. That is the event horizon, the point of no return. If you approached too close and were pulled in, the last image seen before disappearing would appear frozen forever. From your own perspective, you wouldn't even realize you'd fallen in. But to an outside observer, your final moment would seem frozen forever. Your time would stand still. That may sound complicated and rambling, but our understanding of black holes is truly very limited. Many people still imagine black holes. So how does velocity affect time? As mentioned, if we travel close to the speed of light, time around us would virtually stop, and you could almost touch time itself. An abstract concept because nobody has ever reached that speed to verify this. But in reality, this is already happening every day. Artificial satellites, the devices that allow us to use electronic maps like Google Maps, must travel at around 7.9 kilometers per second to stay in orbit. At such speeds, the clocks on those satellites tick more slowly than those on Earth. Engineers must adjust their timing every day to ensure accurate navigation. This proves that the faster we move, the slower time passes. The speed of light is almost the absolute limit. So what happens if we travel at light speed to the nearest star system, Alpha Centauri, which is about 4 light-years away? If we traveled there and back at light speed, people on Earth would wait more than 8 years. But for those on the ship, the trip might feel like only 3 days. 3 days for you, but more than 8 years for people on Earth. A fascinating goal for humanity to pursue as we explore the cosmos. Yet this feat is virtually impossible. So why do we still dream? Because if we cannot travel close to light speed, we may never reach the stars. Without such journeys, the universe will remain a beautiful but distant sky, forever out of our reach. And so, even if light-speed travel remains forever beyond our reach, we continue to look up, driven by our curiosity, creativity, and boundless imagination. Every question, every dream carries us one step closer to understanding the cosmos and our place within it. Until then, let's treasure this endless quest for knowledge, knowing that even the journey itself is a miracle. Every great invention begins with a crazy idea, and if someone calls you crazy, show them that you can make that dream come true. Let's wait and see what wonders humanity's brilliant inventors will create in the future. And don't forget to subscribe to our channel so you don't miss other amazing videos about the universe. Goodbye, and see you next time.